let's take a look at this example. This time we're supposed to find the following voltages. I mean voltage VAB. Voltage VAB is the voltage across these two components, across resistor and inductor. Voltage VBC is the voltage across the capacitor C1 and resistor R2. Voltage CD is the voltage between these 2 points, I mean voltage across capacitor C2 and inductor L2, and voltage XY is the voltage across these 2 components, I mean R2 and L2. We're going to use voltage division law, or some people say voltage divider formula, in order to find the following voltages. Okay, so let's start. We're supposed to start solving this problem from converting the cosine equation to sine. Okay, so what we're supposed to do first, we're supposed to write that voltage source is equal 16 sine, and I have my omega 2000 t, and in order to convert cosine to sine, we're supposed to add 90 degrees to the phase angle. So negative 20 degrees plus 90 degrees gives me positive 70 degrees, and everything of course is volt. Next we're supposed to convert the sinusoidal equation to the phasor equation, and this is equal to, you can say, voltage source equals 16 volts and angle of 70 degrees. We are going to use the polar form. So in order to use voltage divider formula, we're supposed to find the Z total. But in order to find Z total, we're supposed to find first impedance of each inductor and impedance of each capacitor. Other words, we can say we're supposed to find the reactive impedances, right? We have capacitive reactance and we have inductive reactance. I'm going to start from ZL. So impedance of the inductor ZL1 is calculated by multiplying omega times L1. Why omega? Because omega is given. This is my omega. So I can say omega L1 is equal my ZL1, where omega is equal to 2000. Okay, so I have 2000 radians, because omega is expressed in radians per second, times L1, and L1 is equal 1.5 Henry. This is equal 3 kilo ohms and angle of 90 degrees. Remember that you're supposed to always express impedance of the inductor with angle of 90 degrees. Or we can say this is equivalent to J 3 kilo ohms, where this is the polar form and this is the rectangular form. Both forms are correct. So next we're supposed to find ZL2, which is equal omega times L2. Again, omega is equal 2000 radians per second. This is my angular velocity times 1 Henry. Okay, we have 1 Henry. This is equal 2 kilo ohms and angle, of course, because this is impedance of the inductor, of 90 degrees. Or we can say this is J2K. We're going to use most of the time the polar form. Next, we're supposed to find impedance of capacitor 1. So the formula is 1 over omega C1. Please don't forget about the parentheses in the denominator. This is equal 1 divided by omega 2000 radians per second times C1, which is equal 80 nanofarads. Okay, close parenthesis, use the calculator, you're supposed to get the answer 6.25 kilo ohms. And remember that the impedance of the capacitor, or capacitive reactance, goes always with angle of negative 90 degrees, or you can say this is equal negative J 6.25 kilo ohms. Okay. Next, we're supposed to find impedance of capacitor C2, which is equal 1 divided by, open parenthesis, don't forget about the parenthesis, omega C2, which is equal 1 divided by, open parenthesis, 2000 radians per second times the capacitance of capacitor C2, which is equal 60 nanofarads. This is equal, of course you're supposed to use the calculator, 8.33 kilo ohms, and angle, of course, negative 90 degrees, because the impedance of the capacitor goes always with angle of negative 90 degrees. So we found the impedances of inductors and impedances of the capacitors. So what we're supposed to do next, we're supposed to find the total impedance of these two components connected together, and after that we're supposed to find impedance BC, which is going to represent capacitor C1 and resistor R2 combined together, and we're supposed to find the impedance CD, which is basically the representation of these two components together. Okay, so we have Z, A, B. We have resistor and inductor connected in series. That's why we're supposed to add both impedances. So I'm supposed to say this is equal R1 plus ZL1, where R1 is given is 1.6 kilo ohms plus ZL1, which is equal over here 3 kilo ohms and angle of 90 degrees. This is equal, you're supposed to use the calculator, 3.4 kilo ohms and angle of 61.92 degrees. Okay. Next, we're supposed to find Z BC. Okay. So we have resistance R2 plus impedance of capacitor C1, which is equal, R2 is 820 ohms plus ZC1, okay, so this is the impedance of my capacitor C1, 6.25 kilo ohms and angle of negative 90 degrees. Of course, you're supposed to use the calculator. You're supposed to obtain the value of 6.3 kilo ohms and angle of negative 82.52 degrees. Okay, so this is the impedance of the resistor R2 and impedance of capacitor C1 together. Next, we're supposed to find the impedance DC. Okay, so I have Z DC, okay, or we can say ZCD, this is the same thing, so we can say ZCD is equal capacitor C2 plus inductor L2, I mean the impedance of capacitor C2, so I have C2 plus ZL2. I'm talking about these two components together. This is equal ZC2 8.33 kilo ohms and angle of negative 90 degrees plus ZL2, which is equal 2 kilo ohms and angle of 90 degrees. Okay, this is going to equal 6.33 kilo ohms and angle of negative 90 degrees. Okay, so we found the following impedances: ZAB, ZBC, and ZCD. Now, if you are going to add all of them together, you're supposed to get Z total. So, Z total you can find in two ways. Let me show you two ways. Okay, so if Z total is equal ZAB plus ZBC plus ZCD. Okay, this is equal ZAB. ZAB is equal 3.4 kilo ohms and angle of 61.92 degrees plus ZBC. ZBC is equal 6.3 kilo ohms and angle of negative 82.52 degrees plus the impedance ZCD, which is equal 6.33 kilo ohms and angle of negative 90 degrees. Now, plug in these values into the calculator. You're supposed to get approximately 9.88 kilo ohms and angle of negative 75.82 degrees. This is my Z total. Now we are going to find the impedance of these two components together, I mean R2 and L2, because we have to find voltage X, Y. So Z XY is equal R2 plus ZL2, where R2 is equal 820 ohms plus ZL2 is equal 2 kilo ohms and angle of 90 degrees. Use the calculator and find ZXY. You're supposed to get the value of 2.16 kilo ohms and angle of 67.7 degrees. Now we can use voltage division law to find the following voltages. Now, so in order to find VAB, you're supposed to multiply voltage source by the impedance ZAB and everything divided by Z total. Okay, this is the voltage division law or voltage divider formula. All right, so we have voltage source equals, I'm going to use polar form, 16 volts and angle of 70 degrees times ZAB, where ZAB is equal 3.4 kilo ohms and angle of 61.92 degrees over Z total, which is equal 9.88 kiloohms and angle of negative 75.82 degrees. Use the calculator and you're supposed to get the value 5.5 volts and angle of negative 152.26 degrees. So this is the voltage across these two components. Next, we're supposed to find voltage VBC. VBC is equal voltage source times ZBC over Z total, where voltage source is equal 16 volts and angle of 70 degrees times ZBC is equal 6.3 kiloohms and angle of negative 82.52 degrees over Z total, which is equal 9.88 kiloohms and angle of negative 75.82 degrees. Again, you're supposed to use the calculator, and the value of VBC has to be equal 10.2 volts and angle of 63.3 degrees. Okay, so this is the voltage BC. Next, we're supposed to find voltage CD, okay? So voltage CD is equal voltage source times ZCD over Z total. This is equal 16 volts and angle of 70 degrees, open parenthesis, ZCD is equal 6.33 kiloohms and angle of negative 90 degrees over Z total, which is equal 9.88 kiloohms and angle of negative 75.82 degrees. Close parenthesis. Again, you're supposed to use the calculator, and VCD must be equal 10.25 volts and angle of 55.82 degrees. Okay, so we found voltage CD. Next, we're supposed to find the voltage between these 2 points. Voltage across the impedance ZXY, which is combination of resistor R2 and impedance of inductor L2. So we're supposed to write the formula first, like always. VXY is equal voltage source times ZXY over Z total, where voltage source is equal 16 volts and angle of 70 degrees, open parenthesis, ZXY is equal, we found it over here, 2.16 kiloohms and angle of 67.7 degrees over Z total, which is equal 9.88 kiloohms and angle of negative 75.82 degrees. Close parenthesis. This is equal 3.49 volts and angle of negative 146.48 degrees. Okay, so this is my voltage Vxy. Now someone is going to say, okay, we solve basically everything, whatever we're supposed to solve. So, but it's always good to check if our answers are correct. So in order to check our answers, we're supposed to use KVL, Kirchhoff voltage law, which says that if you are going to add the voltages VAB and VBC and voltage CD together, you're supposed to obtain voltage source. So let's check if it will work. So if voltage source is equal VAB plus VBC plus VCD, where VAB we found is equal 5.5 volts, an angle of negative 152.26 degrees, plus VBC equals 10.2 volts, an angle of 63.3 degrees, plus VCD is equal 10.25 volts and angle 55.82 degrees. If you are going to use the calculator, you're supposed to obtain the value 15.99 volts and angle of 69.99 degrees. So please notice that the values which I obtain are extremely close to the voltage source value which was given at the beginning. Because 15.99, we can say this is approximately 16, and 69.99 is approximately 70. So we can say that the problem is solved correctly.